Today I want us to look at the gradient. Are you?
Yes.
Now this gradient you are talking about is the same gradient that you will be learning to 10 level further. Okay?
Yes.
Now, there's a quite definition of what is a gradient, but it's not here. Are we clear?
Yes.
Now, in other words or in other English, when they say gradient, they are referring to a slope. They are referring to a what?
Slope.
A slope. Now, a slope we are referring to how steep or how steep is an environment or whatever. But here, we are talking in terms of what?
Straight line.
The slope of a what? Of a straight line. So, since we are talking about the graphs here, make sure that the graph is a what?
Straight line.
If it's not a straight line, we cannot find what? The gradient or the gradient. Again?
Yes.
Now, then if we then use the gradient, or we find the gradient or the slope of a straight line, we have to use two or more points of coordinate. Again? Remember, the point of the coordinate, we're talking about x and y. Are we clear?
Yes.
Now, to determine what? The gradient. Sure.
Yes.
Now, there's a specific formula in which that we use, or that is being formulated, which is y2 minus yy divided by x2 minus xy. Are we clear?
Yes.
But we get to it when we go there. Now, the shape in which that it is determined, or the shape in which that we use to find the slope, it can either one of the two, shape number A and shape number B. Are we clear? Yes. So I will use this space to determine shape number A. Now when we see shape number A is coming from the left upwards, going to the right downwards. Are we clear?
Yes.
But the correct part about it is a straight line. Is a what?
Straight line.
So we say when the shape comes from the left upward, going downward to the left, so to the right, then we say that the gradient, or so we say that the graph itself is what? Is decreasing. Now when we say it's decreasing, then what about the gradient? The value of the gradient that you are going to find is what? It's negative. It's a number, but it's going to be what? A negative. Are we clear?
Yes.
Sure.
Yes.
Now, but then someone can ask, what do you mean, sir? What do you mean, Menya? Now, we have the set of y-axis, again? Yes. And the set of x-axis. Are we clear? Yes. When I plot my x here, I plot my y here, then here it's 0, it's initial, again? Yes. Then I put my point 1, 2, 3, 4, 5, again? Yes. Then I plot my y's 1, 2, 3. I can go upward to 4, 5, 6, 7. Then I put my negative part of x. Negative 1, negative 2, negative 3, negative 4, up. Again? Yes. Then I put my negative y's. Negative 1, negative 2, negative 3, negative 4, going downward. Are we clear?
Yes.
Then by any chance, using the straight line ruler or using a ruler, we draw a line coming downwards like this one. Sure.
Yes.
The line is straight. Lebona. Can you all see? Now, when the line is straight, it means it's an example of number A. Are we clear?
Yes.
Now, which means when the type of the graph that is here, it's a straight line. Again? Now, in the straight line, what is it doing? The straight line is decreasing. Is what? Decreasing. If we then now have to find the gradient of this straight line, we are going to find that the gradient is a negative number. Are we clear?
Yes.
Any represents any number. The gradient will be a negative number. Sure.
Yes.
But then, some can ask, how can we then find that gradient to see that it's a negative? Are we clear?
Yes.
I will answer that question later. Now let's go to the slope number B, or the straight line of number B. Yes. The straight line of number B, we see already. Coming from the left, it's downward. Again? Yes. Going to the right, it's upward. Can you see?
Yes.
There is a straight line drawn from the left to the right going up. Then we say that the straight line is what? It's increasing. Then when we have to determine the gradient of this straight line, we find that the gradient is going to be what? The positive number. Are we clear?
Yes.
Now going to the set of x is like this one. Set of x is here again. I will draw the other one here. Set of x is again here. Then we find our slope that we are talking about, or the straight line we are talking about, is drawn like this one. Can be the other one C, can be the other one B. Lebona?
Yes.
The graph is drawn like this one. So, in your books, in your classwork books, in your textbooks, in your workbooks, anywhere, wherever you will see the graphs, Are we clear? Of a straight line. The graph will either be of this shape, like this one. It may not be passing only on this point. Some graph may be passing here, some may be passing here, some may be starting here, going to this side, some may be starting here, going to this side. Are we clear?
Yes.
But what must you know about this graph? You must know that this graph is decreasing. When I have to find the gradient of this graph, the gradient of this graph is going to be what? A negative number. Yes. Now let's go to the positive one. Now when looking at the first number B, we said that the graph itself is increasing. Again? Yes. Now the gradient of this graph is going to be what? A positive. Now what about the shape on the set of axis? On the set of axis, we're going to see a shape like this one. Traveling from the negative axis going to the positive axis, but the straight line is going up, we say it's increasing. Then the gradient of this graph, when we are going to find it, we're going to find it as a positive number. So when you look in your books, you find out that the shapes are not same lines or on the same point. Some of them, they may be passing to one another. Are we clear?
Yes.
But all of this type here, they are the type of graph number B. All of them are positive in terms of gradient. All of them are increasing graphs. Can you differentiate between the two? The first one here, all the graphs are drawn like this one, they are going down. Yes. All the graphs are drawn like this one, they are going up. When they are going up, we say they are increasing. The gradient of the graph when it's going up, we say the gradient is positive. Positive meaning is a number, that is a plus. Negative gradient meaning the number is negative. Are we together?
Yes.
Now let me go to the example of how can we then find the gradient. Remember here I have given you two examples. The first example is in the form of a table. In the form of what?
Table.
Remember they said when we find the gradient we must use what? 2 or more points. Do we have points here? Imam may ask you, do we have points here?
Yes.
No, we don't have points.
We don't have points.
But we have what?
Points.
We have what?
Table.
A table. Now, my question is, can we take out the point of the coordinates from this table? Yes, we can. We have to answer it. Because it's made up of the x and the y. Again?
Yes.
And a point is made up of x and y. Now, let's start. Point number 1. You're buying negative 4 is to negative 3. Again? Yes. Point number 2 is going to be what? Negative 3 is to negative 2. Point number 3? Negative 2 is to negative 1. Are we all clear? Yes. Now, how many points are we having here? 3 points. You see, when you are given a table, it is obvious that you can take out what? The point or the coordinates. Again? Yes. Now, if initially you were given the points or you were given the coordinates, again? It was easy for you to draw what? All the x's will be drawing them, lining them upward. The x's, the y's will be lining them downwards. Are we clear? Yes. Yes. Now going back to the previous topic, this one remember we were calling them the input. This one we were calling them what? Output. But we are no longer there. We are using the variable books. I get? Yes. Good. Now my question was, can we find the gradient of these points? Yes. The answer is yes, right? Yes. Correct. Now, the question comes when we have to say we have y2 and y1 and x2 and x1. Where are those things here? Are we clear? Yes. To answer it, to clarify it to you, you choose between the 3 points. You choose any of the 2. We have point number 1, we have point number 2, we have point number 3. Let me allow you to choose 2 of these points. Which one do you choose? So that we can find the gradient about them.
1 negative 2.
You must choose 2 points. 1 and 2. How many of you say 1 and 2? Let's see if you say 1 and 2. Only 1, 2, 3, 4, 5, 6, 7. Okay, the one who are saying 1 and 3? Only 1. The one who are saying 2 and 3? Obvious, we are taking points 2 and 3. Again? Now, when we take points 2 and 3, it's up to you. It's what? Not to me. Yeah, you have to say it's up to me. It's up to you. I guess now, when I say it's up to you, remember with this formula, it must be in your mind. You won't find it anywhere. You must know it. I guess. Now, when we choose point number 2 and point number 3, now we are having two coordinates. Again, or 2 points. Now, point number 2, it becomes all our set of x's as number 1, number 1. Are we clear? X number 1 is y number 1. Hello?
Hello.
Then point number 3 is going to become what? X number 2 and y number 2. Are we clear?
Yes.
X number 2 and y number 2. What is the formula? The formula is going to say y number 2 minus y number 1 divided by x number 2 minus x number 1 is equal to, let's substitute again. Y number 2, what is the value of y number 2? Y number 2. Negative 1, very good, which is negative 1. Then I put negative here because it's negative again.
Yes.
Negative. Y number 1, what is the value of y number 1? You say?
Negative 2.
Negative 2. This is the value of y number 2 again. So number 1 again. That is negative 2 again. Now, if you were clever enough, you will put it in the brackets because it's negative and negative again. Then divide by. Let's go. X number 2 is negative 2, right? Then you put negative 2, then there's negative in between again. Minus, then x number 1? Negative 3. Then others will put the brackets like this one again. Like I say, it's important as a grade 9 learner to use a calculator or to have a calculator. You see now? Now it's like this personal. Only people with a calculator will find out the answer is correct. The rest of us, we will not be sure. Because if you don't know, it is not here. You will never know. The answer here, it gives us 1 divided by 1. Now if you have a calculator, the answer automatically is going to give you 1. Right? Which is what we want. From here you just punch on the calculator, the answer will be 1. Then you are good to go. Now, is my gradient positive or negative? It is positive. What about the shape of the graph? The shape of the graph, will it be A or will it be B? Will it be what? B. Now, will the shape of the graph be increasing or decreasing? Increasing. It will increase, right? Yes. So remember, you were not given the shape of the graph, but you were given the points. Are we clear? Yes. Given the points, you found what? The gradient. Found the gradient, now you are able to determine the shape of the graph. You are able to determine if the graph is increasing or decreasing. Sure. Yes. Now let's do the second example and see if it's the same gradient of positive or the gradient is negative now. Are we clear? Yes. Now, anyone, can we find the coordinates or the points from this table? Can we find or determine the coordinates from this table? Yes. Coordinate number 1 will be 1 and 4, very good. Coordinate number 2? 3 and 2. You say? 3 and 2. 3 and 2, very good. Coordinate number 3? 4 and 1. 4 and 1. Wonderful. Again? Now can we find the gradient between the 2 or between the 3 points? Can we find the gradient? It's my question. You answer it. Can we find the gradient from here? Yes. Yes or no? Yes. Yes, right? What is the formula of the gradient? Yes, here. You say y2 minus y1 divided by x2 minus x1. Okay, is equals to substitute. Well, anyone can substitute? It means we have to go. You see now, it becomes difficult when you have more points. I guess. Yes. But what we want is you must have what? 2. At least 2. At least what? 2. Now remember when we have 2 or more. Here in this case it's 2 or more because it's plus 2. Again, it's more than 2. So what we want is to choose. We have to choose only what? 2 points. So it's up to you. We have 3 points. Now choose only 2 points. Someone can choose 1 and 2. Someone can choose 1 and 3. Someone can choose 2 and 3. But the fact is that if all of these points are on the same line, they will give you the same answer. Langwa? Yes. Now, let's go. Which one do we choose? Kakwan choose 1 and 3, right? Is it 1 and 3 or 2 or 3?
2 and 3.
It was 2 and 3 this side, ne? Yes. Now come, let's choose 1 and 3. Let's choose 1 and 3, right? Yes. So when we choose 1 and 3, it means point number 1, they become x1 and y1. Are we clear? Yes. Point number 3, they become x2 and y2. X2 and y2. Now, our y2 is what? 1. It's 1. It's 1 minus our y1 is what?
Minus 4.
It's 4. Then divide by our x2 is what? 4. Is 4 minus our x1 is what? 1. Good. Then it's equal to, if you have a calculator, the answer will automatically gives you what? Minus 1. And if you don't have a calculator, you can't do it. You can't. You can't, no matter what, you can't. Okay, if you can, come. Okay, speaker. 1 minus 4. Arik, what is the value of 1 minus 4? 1 minus 4? Minus 3 divided by 4 minus 1? 3. And the answer is minus 1. Now, if the gradient is negative 1, right? Yes. It means our gradient itself is a negative number. Are we clear? Yes. It's a what? Negative number. Now let's go between number A and number B. Where is our gradient falling? A. It means our gradient is a negative number. The graph itself is what? Decreasing. Which shape? This one, again? Yes.